Hey folks, Mandic Really here, and I am so excited that I finally found a water block for my RTX 3080, so we are going to water cool it in this video right here. We're going to see whether or not... Oh, what's that? Oh, water blocks for the RTX 3080s have been available since right around the time they launched, huh? Yeah, see, the card that I have is not a reference PCB, it's a custom PCB. It's a Gigabyte Gaming OC 10G RTX 3080. Combine those, shuffle them around somehow, that's the name of the card that I have. As such, a standard like EK reference block doesn't fit this card, and for months I was unable to get a water block for it, and I was just running it on air cooled. I know. Oh, you poor baby, you had to run your 3080 on air. First world problem as hell, especially right now. But the thing is, my workstation is sitting right next to me while I'm working all day long, and the fan noise on that thing, and we'll definitely compare this as we go through here, started to really annoy me, and I wanted to water cool this card just to dial down the noise a little bit. And also, I've been water cooling for literally 20 years, so I just enjoy doing it. Let's dive into this, taking a look at the parts we're going to be using for this setup, put it on the card, and then do some comparisons to the air-cooled versus water-cooled and all of that. Let's do it. When I picked my CPU water block for my system, I had a range of choices on the market, but I actually really liked the look of this Bykski block that I have on here. And that's one of the reasons I picked it. The other reason was, well, affordability. It was actually pretty reasonably priced when I got it. It just so happened that Bykski is the only company that I could find, at least when I ordered this block, making a block for this GPU. The block in question is the N-GV3090GMOC-X, so eloquently named water block. Let's go ahead and unbox this, take a look at what comes in here. Right away when we open up the box, first thing we find is an RGB fan controller setup. But one of the things about that is for RGB on the Bykski blocks, they use a 3-pin connector that is not your standard 5-volt 3-pin addressable connector. It's a different design. Luckily, at least in my case, both my CPU and GPU block have come with harnesses to adapt to your standard 3-pin 5-volt RGB. In the bag with that RGB pigtail is also the thermal pads and hardware to install this block onto the card. And the last thing that came in this box is what I think is the star of the show here, the pigtails that actually adapt this Gigabyte card to a standard PCIe connection. This is the thing that nobody else that I have been able to find on the market is currently offering. We'll talk about that a little more as we get the card disassembled and reassembled with the water block. Which brings us to the card itself. This thing is a copper design with nickel plating and an acrylic top on it. It has a very nice clear acrylic when you're looking dead on at it, so if you're putting this in a vertical position, it would look really nice in that regard. And then it has a frosted edge to it. The terminal block for the fittings on the block is a acrylic piece with 3 bolts going into it, and it is fully frosted. So if you were using this in a vertical configuration, it might look a little out of place with the rest of this being all kind of like clear, polished up, but in the horizontal configuration, like I said, doesn't matter. Let's go ahead and take a closer look at the design of the block itself. We of course have the micro fins for the heat transfer from the GPU. We have the nice directional design forcing that coolant into the center of those fins. I like seeing that. It's not a more generic design that some other blocks use. But when we start to look a little closer at the design, the actual machine work of the piece, I noticed the first thing I don't love. As somebody who is a fabricator by trade and somebody with machining experience, I started to notice there's quite a bit of tooling marks in the actual channels of this block. Now, is that the end of the world? By no means. It's just by no means the most quality looking machining that I've ever seen on a block by any stretch of the imagination. And when we flip the block over and we look at the back side of it, the area that's actually going to interface with the components on the card, we can see we've of course got the multi-step design to this, so the memory chips and the VRM are getting their cooling, and then in the block terms anyway, recessed design for the GPU. And that brings us to what I'm going to say is the worst thing about this block. The machining on the actual cold plate that's going to go to the GPU is terrible. All those things I was seeing in the passages on the front side of the block are translated right to that GPU cold plate. When you compare the die area to the memory and the VRM areas, it is a night and day difference. They did such a better job on those pieces that arguably didn't need as good of a machine job on them. You gotta remember the VRM and the memory, they're using thicker thermal pads. The GPU die is gonna be using thermal paste, which is gonna be more finicky about a good surface finish. My educated opinion on what's going on here is the cutter that they used to do a cleanup pass on the VRM and memory area was too large to get down into the die area of the block. Because you do have to remember the different components of the GPU are at different heights off of the PCB, and the tallest one that they are concerned about interfacing with is the GPU die itself. That means that the memory and VRM areas of the block are sticking off of the block surface more. So they could get a really nice, clean, slow pass over those areas that they just couldn't get down into that die to get. So they used a much smaller tooling and just kind of blasted through it. I think they really could have done a better job with that, even with a smaller tool. A last finish pass cleanup at a slower travel speed would have probably done the job, but I'm not in their machine center to see how they're doing it or what they're doing. Time to grab my tool set and go ahead and pull out the card and start putting this block on it. Disassembly of this card was far more straightforward than I expected it to be. I just had to remove the obvious screws on the backside of the card, and the cooler came off pretty easily with little force. There are 3 connectors I had to get off of there for the RGB and fans on the cooler itself, and now we can take a better look at that cooler off of the card. I just wanted to show you a little bit. It is a serious cooler. They've really put some effort into this 2.5 slot cooler, and that's something I'm really looking forward to with the WaterBlock is I'm gaining back a PCIe slot. Now it's only a 1X slot on this motherboard, but that cooler was blocking up a 1X slot that I couldn't use for anything previously. With the water cooling, I'm going to gain that back. Now that we have the cooler off the block, we can take a better look at the card itself. Just take a look at the beauty that is the RTX 3080. When you compare it to a reference design, the PCB on this is really not that much different. The big difference is that annoying design for power connections. I don't know why, but Gigabyte insisted on going to these flat connectors at the end of the card with a little pigtail harness. Now these flat connectors are where these pigtails that Bykski provides come into play. They are the only manufacturer that I am currently aware of providing this harness adapter setup for this block. These pigtails provided by the folks at Bykski are long enough that they can actually get through the grommets on my Lee & Lee PC011 Dynamic XL anyway, and then I can make my PCIe connections in the back section of this case completely out of view. I thought about trying to sleeve these cables myself, and I still may do that down the road, but at the moment I just want to get this thing up and running. Removal of the backplate is also easy. It just requires a few screws that were hidden by the cooler to be removed so that it can be separated from the card. Now it's assembly time, and as I've experienced in the past with other companies like Barrow and, well, Bykski, the instructions don't exist. They just really don't provide you with anything. Luckily on this card, it doesn't seem to be too big of an issue. I've had other blocks on other cards where you need to have different thicknesses of thermal pads in different positions. This one uses the same thickness of thermal pads all across the card. So all I really had to do was look at the block and see what components on the card were going to come into contact with the block itself and put thermal pads where they needed to be, as well as applying that thermal grizzled cryonaut to the GPU core so I could go ahead and get this card assembled. Again, with the lack of instructions, figuring out the exact stack of what screws went where and what spacers were needed was a little bit confusing, and this is the configuration that I personally ended up using. And unfortunately, there was far more hardware left over than I care for. It's like when you put together IKEA furniture and you end up with that extra hardware at the end and you just question yourself, is that actually extra hardware or did I screw up? And the last step for assembly of this is, of course, the backplate. Backplate that came with this thing, which yes, it did come with the backplate. You didn't have to buy that extra or separately, which this block is not cheap by any means, so good. The backplate is black. And with the nickel-plated block and the acrylic face on it, I would have liked that to be nickel-plated or raw aluminum maybe. The black just doesn't quite fit the aesthetic that I'm going for. I thought about sandblasting and polishing it myself, but I really didn't have the time to put into that before I assembled this card, unfortunately. And here's a comparison shot of the newly assembled RTX 3080 with the Bykski block on it and the 2.5 slot triple fan cooler that the card came with. It's so interesting to me to see how big the coolers are on these 3080s and how little the card is in comparison. Alright, now it's time to actually put this card back into the system and get it plumbed into my water loop. Now the system that I'm running here has two 360 radiators that were previously only cooling the CPU while I had the 3080 air-cooled, so I'm not too worried about adding additional radiators or changing things in that regard. I think I've got the cooling capacity for this. We will do temperature testing and all of that in this video yet. I decided on a loop order of pump to GPU, from GPU to radiator, radiator to CPU to radiator back to the pump reservoir combo. I did that because I liked the clean look of the way that it ended up routing this way, as well as I wanted to keep the hoses as long as I could. Yes, I am running flexible, soft hoses in my system, not hard lines. I do this because this is a workstation computer, and as such, if my CPU needs to be swapped out, if I need to reseat my graphics card, just something happens where I need to service the system, I don't want to have to drain the system every time I want to work on it. Alright, time to fill this water loop, and then we're going to go ahead and do some benchmarking. I did some pre-benchmarking with the air-cooled card in a couple of games and saved those results. Now we're going to do some water-cooled benchmarks, compare the temperatures we're getting, and see if there's any performance improvement on this card at all. As far as benchmarks, I ran 3 tests. I ran 3D Mark Time Spy, Unigine Heaven, and Borderlands 3. Now, I also want to note that I am streaming now. Why do I want to note that? Not just to name drop the fact that I am streaming, but also because I was running Streamlabs OBS and recording while benchmarking all of these tests. The reason that I did this is because when I'm gaming these days, I'm streaming at the same time. So for me, real world application of this card was having Streamlabs running in the background with the NVENC encoder going. Quick note, here are my overall system specifications so you know what to expect. I had some people on my last video tell me, your numbers don't match the Puget numbers. Yeah, Puget was running 32 core Threadrippers on their test benches. I'm not. And without further ado, here are our numbers. I'll come in with a couple of notes here at the end. Overall, the scores that I got here are basically what I was expecting. Mild improvements over the previous numbers I was getting on air. Honestly, this RTX 3080 is rather limited, mostly in power and BIOS ways. It's only got 2 8-pin connectors on it. The BIOS is locked down, so I can't crank up the power target limit, and I can't undervolt the card either to try and improve it that way. The only outlier in that testing was Unigine Heaven. You can see here my minimum FPS that I got between the air-cooled and the water-cooled testing. That 9.4 FPS is not a fluke. I ran that test numerous times, and I was getting consistently right around 9 to 10 FPS minimum on that card on air in Unigine Heaven at 1440p. I do not know why. If you have an opinion as to why the air-cooled card was dipping so much, please let me know in the comments down below. I can't wrap my head around it. Same drivers, everything else in the system's the same, I don't know. But let's face it, the real-world test was Borderlands, the other two were just synthetic benchmarks, and it was barely a 2 FPS increase from air-cooled to water-cooled, and that's really what I expected to see here. Let's do the noise comparison. Side panel off on both of these just for the worst case scenario while running benchmarks. So overall, was this worth it? No, probably not. I enjoy water cooling. I like what I have put together here. But at the almost $200 that this block cost and how long I had to wait for it to ship into me, really, it probably wasn't worth doing. Maybe another block would have been more worth it, something that had better GPU contact, I don't know. The temps that I'm getting are pretty darn reasonable. I dropped the GPU temp by 8 degrees Celsius while running a stress test, namely running Unigine Heaven and just looping it over and over again. So that was where I topped out on GPU with water at 56C. But in the same regard, the CPU came up 7 degrees to 73 Celsius. So Obviously, I put more heat into the system. It doesn't seem to be negatively affecting my CPU. My score on 3D Mark CPU score actually came up between water and air. One final note that I want to make, I did that whole previous video talking about using a 3080 for a workstation card. Now, there's been some driver maturity, programs have matured a little bit since I made that video, so let's discuss that real quick. In that video, TLDR, but I would appreciate if you still go watch it, I said that I don't really think the 3080 was particularly worth it for my workflow and my content creation needs. However, I have kind of turned around on that. You see, the biggest thing that I saw an improvement with was export times on videos. And when you're talking about a 15-minute YouTube video like this one, that's not that big of a deal. I save a couple of minutes in my day. However, I got a freelance job shortly after I did that last video, and the deliverable was over a 1-hour video with multi-camera editing, all of that. I saw a big performance improvement. That reduced export time paid dividends on such a large project. The customer wanted a couple of changes within the edit. I noticed a few issues within the edit, so I ended up exporting that video 4 or 5 times till it was all said and done. The amount of time I saved on exporting was actually noticeable to the overall project. That one project, I honestly think, paid for the RTX 3080 and justified having it for me. So going forward, I think I've turned around on this RTX 3080. Between my streaming uses, I've been streaming Cyberpunk 2077, getting consistently 55 to 60 FPS while streaming. I'm playing at 1440p with ray tracing and high details on. Streaming at 1080p output, it's been doing beautifully for me. In that regard, the RTX 3080 has suddenly become worth it. Water cooling it? Maybe not so much. Alright folks, I think that's gonna wrap it up for this one. Go ahead and drop this video a like if you found it interesting. Let me know in the comments down below. What do you think about this? Are you gonna water cool your 3080? Have you BIOS unlocked your card? Let me know in the comments down below. Get subscribed to keep up to date with the tech content I make on this channel. Thanks for coming around, folks.